All right, determining zeros and in behavior. All right, what is this? All right, well, in behavior is when you have a graph of a polynomial, and say it does this right here. All right, the in behavior is what the two ends end up doing, because this thing's gonna curve up and down, but eventually it's gonna just play out where it just goes on forever, up or down, like these two do. Okay, so sometimes you might have one that does this, where both the left side and the right side are up. You might have the left side down, the right side up. You could have it this way. The left side up, the right side down. Or, like these are both up, you could have them both down. Now there's a real easy way to determine what the in behavior is. And so let's look at this right here. It's real simple. See this equation, this is a function. Okay, what you look at on this is the lead term, which is right here. This is to the fifth power. That's third, that's 1, that's x to 0. But the fifth, this is 2x to the fifth power. That's my lead term. Okay? Now, what we do is, since this is positive, you got a left side and a right side. Since it's positive, that means the right side goes up. Okay? And then you look at your power. Since your power is odd, if it's odd, that means these two do opposites. Odd, opposite. So that means this one will go down. So my answer here looks like B. The right side goes up, the left side goes down. And that's how simple it is. Real simple. Number 2. What's my in behavior here? Well, my lead term right there, negative 2x to the third power, which means since it's negative, the right side goes down. The right side goes up if it's positive. The right side goes down if it's negative. All right, then you look at your power. The power is odd, which means opposite. This does the opposite. So we're looking at D right here. Okay. What about 3? Determine this one. Well, my lead term is 7x to the 6th power. Okay. It's positive, so the right side goes up. Automatic. The right side is up because it's positive. See my power? It's even, which means they do the same. So this one's up too. So we're looking at C right here. That's my answer. Okay. And then the fourth one of these, there's 4 of these like this. My lead term. Now these are not in order here, but here's my lead term right here. See the sign in front's negative? Negative 3x to the 10 power. Okay. Well, it's negative, so that means the right side is down. Okay, then you look at your power is even, which means they do the same. So the left one is down also. So we're looking at C here as my answer. Okay, that's how you do in behavior. Now we've got some more of that on this page here, the next problems, but we've got more things to do. Now describe the in behavior. Now I didn't explain this all the way here. Let me go back to this and show you now. On my in behavior like this right here. So what this means on the left, it goes down. So that means as x approaches negative infinity, then the function of x approaches, this is going down to negative infinity. All right, that's what this is right here in mathematical terms. And then this side right here, as x approaches positive infinity. See, as x goes this way, the function is going down, so that means the function of x approaches negative infinity. All right, so as x approaches negative infinity, that's the left side. As x approaches positive infinity, that's the right side. This is the left side, that's the right side. Okay? So let's just do this. Suppose we have one that does this on that side and it does this on that side. Okay, let's say these are my in behaviors. Okay, so on this one right here, as x approaches negative infinity, the function of x approaches, it's going up, positive infinity. On this one, as x approaches infinity. All right, this is going down, so that means the function of x approaches negative infinity. So here's what's happening with these arrows. That's what these arrows mean. Okay? so let's look at this one here. Look at my end behavior on this one. Well, on the left side, it's going down. So let me write right here. The left side's going down. On the right side, it's going up. Okay, you see that right here? The left side's going down right here. The right side's going up. All right, so that means on this one here, as x approaches negative infinity, the function of x approaches, this is going down, so it's negative infinity. On this one here, we're going positive infinity. There, see, this is infinity, that's negative infinity. So as x approaches positive infinity, the function of x also approaches positive infinity because this one's going up. Okay? Now, determine if this is an even or an odd function. All right, so when they do opposites like this, that's odd. So this one's odd. See, this one's going down, this side's going up. When they're opposite like that, that's odd. Now, if they're both going up or they're both going down, that would be even. And then it says state the number of real zeros. All right, there's a 0 right there, there's one right there, there's one right there. So this has 3 zeros. Okay. Now, what they are, this one looks like it's -2, that looks like it's -3, and this looks like it's +1. Okay, we'll go do another one here. All right, so describe the end behavior here. So on this one, we can see it's going down on the left, and it's going up on the right, which is what the previous problem did. So on this one, this is negative. This is going to negative infinity. So as x approaches negative infinity, the function of x is going down. So that means the function of x approaches negative infinity. This one here, we're going to positive infinity. So as x approaches positive infinity, the function of x is going up, so that approaches positive infinity. Okay, this is going down, that's going up, so this is odd. And then the number of zeros, looks like I have 1, 2, 3 zeros. Now they look like this is -7, this looks like -3, and this 0 looks like +1. So there's my 3 zeros right there. Okay, here's another one. Okay, describe the end behavior. Well, the left side and the right side, they're both going down. All right, so on this one, as we go to negative infinity, as x approaches negative infinity, the function of x approaches, well, it's going down, so that's negative infinity also. On this side, that's going to positive infinity. So as x approaches positive infinity, the function of x is going down there, so that's going to negative infinity too. Okay. Is this even or odd? Well, they're both going down, so that's even. And the number of zeros, looks like we have 1 there and 1 there, so there's 2. This one looks like it's -4. This one looks like it's +1. So that's what values they are. Okay. This next one here. All right, well, this side's going down, this side's going down. So they're both going down. All right, so as we go to negative infinity, as x approaches negative infinity, this is going down. So the function of x approaches negative infinity. All right, as this side, here we go to positive infinity. Okay, so as x approaches positive infinity, the function of x is going down. So it's going to negative infinity again. All right, is this even or odd? Well, they're both going down, so it's even. If they both go down or both go up, it's even. But if they do opposites, that's odd. Real zeros, looks like we have a 0 here, here, and here. So it looks like 3 zeros. This one looks like it's at -3, that's at 0, and this one's at 2. There's what my 3 zeros are. Okay. What about here? Describe the end behavior. All right, this side's going up, this side's going up. So both sides are going up. Okay. Well, as this one goes to negative infinity, as x approaches negative infinity, the function of x is going up. So it approaches positive infinity. And as x approaches infinity, as we go this way to infinity, this one's going up again. So they're both going up to infinity. And that's how you write this out. Is this odd or even? Well, they're both going up, even. And then the zeros, one there, one there, one there. This has 4 zeros. Looks like -3 is 1, -1 is 1, 1 and 2. Here's my zeros right there. Okay, so what we got here. All right, the left side's going up, the right side's going down. So this is going up, this one's going down. So as we go to -infinity here, as x approaches -infinity, the function of x is going down. So it's going -infinity. I'm sorry, it's going up. It's going up. So as x goes this way, this is going up, so it's going to positive infinity. It's right here. As x approaches infinity, as we go this way, well, this is going down. So f of x approaches -infinity. Or is this even or odd? Well, this is up, that's down, so that's odd. And the number of real zeros looks like there's one there, 2, it looks like 3. This one looks like -1, 0, and then 2. There's my zeros right there. -1, 0, and that one's at 2. Okay, 2 more of these. What about this one here? Describe the end behavior. Well, this side's down, and this side's up. So as we go to -infinity for x, as x approaches -infinity, the function goes down. So that's -infinity. On this side, as we go to positive infinity, as x approaches positive infinity, the function of x goes up. So that goes to positive infinity. This side's down, that side's up. These are opposites, so it's odd. And the number of real zeros looks like it has 1 0 right there, which looks like 1, 2, 3. It looks like 3.5 maybe. It's got 1 0 and 3.5 maybe. Okay, and then one last one here. Describe the end behavior. This one's down, this one's up. So this one's down, this side's up. As we go to -infinity, as x approaches -infinity, the function of x goes down. So that approaches -infinity also. On this side, as we go to positive infinity, as x approaches positive infinity, the function here goes up to positive infinity. And now, is this odd or even? Well, this one's down, that one's up, so that's odd. And the number of zeros looks like there's 1 there, 2, it looks like 3 of them, 3 zeros. This looks like -1, this looks like 0, and it looks like 2. There's my zeros. Okay, so that's it, how it is. It's really simple stuff. So that's determining zeros and your end behavior. If you have any questions, let me know. I'll help you anytime, all right? So have a good rest of the day.